All right, so this video is going to be about literal equations. And all literal equations are basically equations with lots of variables in them. And so our goal is basically solve equations for given variables. This part, literal equations, will probably be a couple videos. So this won't be just the only video on literal equations. So just a heads up on that. So let's look at what I mean by literal equations. What I mean by literal equations is basically we're solving equations for a specific variable. So if I'm given the following equation, sorry for all the moving, I'm trying to get it lined up. So let's say I have x plus 4y equals 19, and I want to solve for x. So I want to get x all by itself. Now, normally what we would do here is if I had this equation and I was solving for x, we'd have something like this: x plus 4 equals 19. Well, I'm going to throw a y next to that 4. So now we have just both different parts here. So we want to get x all by itself. So if this was x plus 4 equals 19, my move would be I would subtract 4 from both sides. Well, what I'm actually going to do is I'm going to subtract 4y. I'm going to subtract this whole thing to the other side. Subtract 4y to this side. 4y minus 4y, those go away. That's 0. Those cancel. Leaving me with x on the left side equals, well, these are not like terms. I can't take 4y from 19. I have $19 and I'm trying to take away 4 yo-yos. Well, I can't take away 4 yo-yos from dollars because dollars and yo-yos aren't the same. So if you can't do the math, literally you can't do the math, not that you just can't do the math, we just rewrite it. So this would be x equals 19 minus 4y. I solve for x. X is all by itself. This is my answer. X equals 19 minus 4y. Boom, that's it. So all we're doing is when I need to solve for a certain variable, I just move everything else to the other side. That's it. So let's look at another one right here. We have 5b plus 12c equals 9, and I want to solve for b. So here's my b. Well, if say I cover up this c right here, it's basically 5b plus 12 equals 9. Well, my move would be to subtract 12 from both sides. And since there's a c with this 12, I'm going to subtract 12c. Subtract 12c, leaving me with 5b, because that's what's left over on this side, equals 9 minus 12c. Again, we need to solve for b. We want b to be by itself. So let's pretend we had 5b equals 9. Well, how would I solve for b? I would divide by 5 now. So we're going to divide by 5. Well, what I got to do here is I got to divide the whole thing by 5. The whole thing has to be divided by 5 because I'm taking this whole thing divided by 5. Leaving me with b, that's what's left over on this side, equals 9 minus 12c all over 5. So b is all by itself now. So b is equal to 9 minus 12c all over 5. All right. Now let's look at this one. This one's a little bit funkier. We want to solve for x. So we want x by itself. We have x times y plus z. Well, what we could do is we could distribute the x and then work from there, but that's going to be a little bit more work. When we see a number next to parentheses, we know that means multiplication. Well, how do we undo multiplication? What's the inverse? So like over here, what's the inverse of multiplication? We had 5 times b. To undo multiplication, I divided. So what I'm going to do here is to undo this multiplication. I want x by itself. I'm going to divide by this whole thing in here, y plus z. And then I'm going to divide by y plus z on this side as well, because those go away. And this whole thing goes away, leaving me with x equals 13 over y plus z. That's it. Because I can't take 13 divided by y. I can't take 13 divided by z. I can't add y and z. So that's it. Boom. So that's solving for a specific variable. Do a couple more examples here. So we have this, k minus 2 all over 5 equals 11a. Well, I'm solving for k. I want this k to be by itself. Well, if I took away this a, we had k minus 2 equals 5. Well, if I want to get k by itself, the first move would be multiply by 5, multiply by 5. These 5s go away, leaving me with k minus 2 equals, well, I can do the multiplication. Remember, adding and subtracting is when we have like terms. We can't do that. Multiplying, we can multiply on like terms. So 5 times 11a is 55a. And again, we want k by itself. Well, we have k minus 2 equals 55a. Well, if I covered up that a, and I had k minus 2 equals 55, I would just add 2, those go away, leaving me with k equals, well, these are not like terms, so basically I have k equals 55a plus 2. That's it. K is all by itself. We're solved. We're going to do this one, because I want to come back to this middle one, because I got a little bit I got to talk about on that one. So here, we want to solve for t. We have t times r plus 4. Again, just like we did up here with this one, we had x times all this stuff. We divided by all this stuff in the parentheses. That's what we're going to do here. We have t times all this stuff. We want to get t by itself. So I'm going to divide everything by r plus 4. Divide this side by r plus 4. Those go away, leaving me with t equals 28 divided by r plus 4. And that's it. My answer is done. Because t is by itself. I can't solve this math, so we're done. All right, and last one I want to look at for this video is this problem right here. 15 equals 3n plus 6p. We want to solve for n. There. So if I had this, let's again cover up this p. If I had 3n plus 6 equals 15, I would subtract 6 from both sides. So I'm going to subtract 6, but I'm going to subtract 6p because the p's with there. Subtract 6p, leaving me with 15 minus 6p equals 3n. All right? So we got here. Well, n's not by itself. Now I got to divide by 3. That goes away. And I got to divide this whole thing by 3 as well, leaving me with n equals 15 minus 6p over 3. Now, we could leave it like this. This is okay. But to help us out when we go further on, if we look here, 15 minus 6p all over 3, we can rewrite this as n equals 15 over 3 minus 6p over 3. These are equivalent. Same thing. Well, if we look, what is 15 divided by 3? 15 divided by 3 is 5. Minus, what's 6 divided by 3? 2. So 2p equals n. So all 3 of these answers right here are all the same. All 3 of these are correct. This one's more correct. This one looks cleaner. And the reason you want to be able to get to this is when we start substituting in, it's a lot nicer to be able to work with this than this. So here, because I knew 15 was divisible by 3 and 6 was divisible by 3, that's why I separated it and do the divisibility. Here, 9's not easily divisible by 5, and 12's not easily divisible by 5. That's why I left it. So when it's easily divisible, we can split it and solve it. But when it's not easily divisible, just leave it. Again, for right now, all three of these are correct. So if you just leave it here, it's not wrong. This is just more correct. It's cleaner. So for right now, because we're just starting this, if you do leave this one like this, that's okay. Try to get it to go to here, though. That's our goal. Okay? All right, so this video is going to stop here. We'll do some couple practice problems, and then we'll look at a couple other things. Hopefully, again, you guys are having fun with this. I know it's a little crazy. Hopefully, you guys are, having fun, hanging in there, not going insane yet. All right. All righty, guys. Remember, email me if you have any questions.